This is section 9.3, hyperbolas. These are the objectives. Write equations of hyperbolas in standard form. Find asymptotes of hyperbolas. Classify conics from their general equations. So here's number 1, says find the center, vertices, foci, and asymptotes of the hyperbola and sketch its graph using the asymptotes. So let's go ahead and find the following information that you see there. Let's first find the center, which is negative 3, 2. In a little bit I'm going to graph it, and I should be able to find the A, the B, and the C. The A is basically the square root of 144, the B is the square root of 25. How do I get the C? I use C squared is equal to A squared plus B squared. Then at this point, I'm actually going to graph the center from here, and then at this point I'm going to plot the following points. Where do I get these points? These points are actually going to help me find the shape of the hyperbola, and in addition to that, find the asymptotes. How did I get these 2 points? I basically traveled A units to the left and right from the center. This is B units up and down from the center. Then, these are my vertices, negative, because they want me to give the vertices. Negative 15, 2, which is this one, and 9, 2. From here, this is where I draw a rectangle, and this rectangle is going to help me find the asymptote. And here are the asymptotes. In a little bit, I'm going to come up with the equation of those asymptotes. And basically, how do I generate the asymptotes? I look at this rectangle, and I connect these 2 corners, or the diagonals, and these are my asymptotes. Then I am going to go ahead and graph the foci, which is right here, because from the center I'm going to travel 13 units to the right, and this is where I end up, and 13 units to the left, and the coordinate value of the foci, there you have it. Now let's go ahead and find the asymptotes. So first let's go ahead and compute the slope. Slope is rise over the run, so that's why you see plus or minus 5/12. Then, at this point, I'm going to go back to what I learned in Algebra 1, which is point slope form. I'm going to plug in the m, and then I'm going to pick a value, x1, y1, which is going to basically be the center. Then, with the point, a point in this on the line, which turns out to be the center. I could have used this point, but it's easier if I use this one that is shared by the 2 lines. Then at this point, once I substitute, I end up with the following, and to give the equation of the asymptotes, I don't have to distribute this, but I do want to solve for y, and this is the equation of the asymptotes, and we can stop at this point. Let's move on to number 2. Similar directions, different problem. So let's go ahead and find that information. Here's your center, negative 1, comma 1. And notice that in this case, the hyperbola is going to be opening up and down because the y variable is the one that is positive. Then I go ahead and graph the point, the center, which is negative 1, 1. This is 1/2. This is 1/4. And then how do I get the c? Using the c squared equals a squared plus b squared. At this point, I actually come up with those coordinate values. How did I get these coordinate values? Again, from the center, I'm going to travel 1/4 to the right and 1/4 to the left. How do I get these points top and bottom? I'm traveling 1/2 unit, half a unit up, half a unit down. Then at this point, I can go ahead and draw the rectangle. This is going to help me find the asymptotes. But before I do that, I'm going to actually give the vertices, which is this. Actually, this one is the one at the bottom here. Negative 1 and 1/2. This one is on the one on top. Negative 1, 3/2, or 1.5. Then I can go ahead and draw my asymptotes. Here they are. I'm going to go ahead and label the foci. And this is the coordinate value of the foci. The x value is the same. The y value is that it's going to change. So from the center, from this point, the y value 1, I'm going to add and subtract the c. And that's why you see that here. Once I estimate 5 radical 4 going up, radical 5 over 4 going up and down, this is where you can find it. This is an estimation. Then at this point, all I need to do is find the slope. The slope is plus or minus 2. You're going up a half over 1/4, and that's how you get 2, plus or minus. Then at this point, again, I use point slope form. Substitute my m, substitute the center, which is negative 1, 1, into the appropriate x and y. And then I solve for y, and this is my answer. And I forgot to mention this on number 1. Like I said, it's kind of hard to sketch with the bamboos, but you should be able to sketch the parabola, the hyperbola, the graph of the hyperbola, opening down here and then opening up here. Let's move on to number 3. Let's look at number 3. Yes, this has 3 parts. This first part says find the standard form of the equation of the hyperbola. Part B, find the center, vertices, foci, and asymptotes of the hyperbola. And last part is graph. You should be familiar with the steps. Just pair up the variables right next to each other. I'm going to have to complete the square. Same process that we have done on the previous sections of completing the square. Now you're going to be there's going to be a subtraction sign between the x and the y, or y and x. So then at this point, all I'm going to do is I'm going to take half of the negative 4, square it, and then add 4, and then I'm not really adding 4 on the left side, I'm adding 100. So that's why I have 100 on the right hand side. At this point, I combine the 300 and the 100, and then I factor that trinomial. I get the following, and then at this point, I'm going to divide everything by 400, and that's why I have the following. At this point, I'm done with part A. Part B says find all that information that you see there. The center is 0, 2. I forgot to mention, notice that this parabola, since the y is positive, is going to be opening up and down. So the center is 0, 2. Notice that I have the coordinate, I graphed 0, 2 on my coordinate plane. There you see it. Then my A, my B, so this is my A, so I'm going to be traveling up 4 and down 4, to the right 5, to the left 5, and that's why I get those points. And then these are my vertices, which is 0, 6 and 0, negative 2. Again, it's opening up and down. The y is positive. Then I go ahead and sketch my rectangle that is going to help me find my asymptotes. Once I do that, this is how the asymptotes look. At this point, I can go ahead and find where the foci go. And all I'm doing to locate these 2 points is I'm going to travel from the center, square root of 41, or approximately 6.4 units up and down. So if I do that, this is a good estimation. Then I'm going to give the coordinate value. So the x value is 0. And then from here, I'm basically adding and subtracting radical 41, which is my c. To find the asymptotes, again, you already know the plus or minus 4 over 5. And then use the center, and then, and then just move the solve for y. And this is what you end up with. I'm skipping a step or 2 here, but it's very similar to what we did on number 1 and 2. Let's go to the next problem. This one is a little bit different. We don't have to graph. Just find the standard form of the hyperbola with the given characteristics. They give you the vertices and the foci. If you sketch this information, this is how it looks. The vertices and your foci. Now, once I have this information, I can find the following. From here, I can find A and I can find C. Once I have my A and my C, I should be able to find my B squared using C squared equals A squared plus B squared and solving for B squared. And I get 16. At this point, I'm pretty much done. Let me get a pen. I know my B squared, I know my A squared, and I can go ahead and find the center, which is very easily done by looking at this point, which is positive 2, 0. Positive 2, 0. And since it's opening up and down because of the vertices, I don't know if I mentioned that earlier, then that's why you have the y squared is positive. Number 5. So different information. Now you have the vertices and a point. 0 radical 5. If you sketch the vertices, you can find the center very easily. 1, 0. And then at this point, this gives me my A. And it's opening up and down because the vertices are basically the transverse axis is vertical. A is equal to 2, and I need to find my B. They don't give me information about the focus, but they do give me a point. So this is what I'm going to do. I am going to just solve for B squared. I already know my center. I already know my A. So I square it, and that's why I have this. And again, it's opening up and down. That's why the y squared is positive. At this point, I'm looking for B squared. The way I'm going to solve for B squared is I'm going to use this x value and y value, plug it in here, and I'm going to have an equation with a single variable, B squared. And if you look at this, 5 over 4 minus what over what number gives me 1. This has to be 4. You can do it algebraically or just think about it and you end up with 1. But anyway, any process you use, you're going to find B squared is equal to 4. Then I'm basically done. I go back, substitute B squared, change it for 4, and this is the answer. Let's go to the next slide. Here's number 6. Same directions as the previous slide. I give you the vertices, then I give you the asymptotes. I'm going to go ahead and graph the information here, the vertices actually. And then at this point, you should be able to see that this is going to be opening up and our parabola opening up and down. So you know it's going to be a positive y something squared. Here's my center, 3, negative 3. And then from here, I should be able to find my A value of 3. From here, I'm going to use the slope. Since it's opening up and down, this is the formula that I use for the slope, A over B plus or minus. I'm just going to focus on the positive A over B. If you look at the given asymptotes, the slope there is plus or minus 1. And again, I'm going to focus on positive 1. You can focus on the negative if you like. It's easier to positive. I set these two equal to each other, and I substitute A, which I found that it was equal to 3. And I just basically solve for B, which you know is going to have to be 3. Once I know my B, I'm pretty much done. This is my center. Plug it in, and then my A is 3, my B is also 3, so that's why this is my answer to number 6. Let's go to the next slide. Classifying a conic from its general equation, the graph of ax squared plus bxy, you can continue reading all the way to x equals 0, is one of the following. Is a circle when the A is equal to the C. It's a parabola when the product of AC, either one is 0, but not both. And then you should be able to follow ellipse when the product of A and C is greater than 0. And number 4 is a hyperbola if the product is less than 0. And this should make sense. And let's move on to the next slide in which we're going to apply this. So it says classify the graph of the equation as a circle, parabola, and an ellipse, or a hyperbola. What is it? You don't have to put it in standard form. Just look at the previous slide, what you saw there. Recognize that you have A equals C, which means that it is a circle. And you're done. Number 8. Look at the information. Look for the A and the C. Turns out to be that the product is equal to 0. And then that's why this represents a parabola. Number 9. Look at the A and the C. And notice that the product is greater than 0. So that's why this is an ellipse. And finally, number 10, which is the last problem in this video, is the conic is a hyperbola because A times C is less than 0. Now, I challenge you to be able to do this without actually using the information that you learned on the previous slide. And it is doable. It's not hard. If you think about it, it should make sense why it is a circle, ellipse, and so forth when that happens with the A and the C. But this concludes the video.